All right, this is 10.1. We're going to talk about radicals today. Hopefully this is a good review for you guys. Okay, so look at the first one on page 596 if you want to follow along. We have the square root of 36. For B, we have the square root of 0. C, square root of 4 over 49. D, we have the square root of 0.25. E, square root of x to the 6th. F, square root of 9x to the 12th. G, the negative square root of 81. And H, the square root of negative 81. So let's start with A. Square root of 36, what is it? It's going to be 6, right? 6 times 6, 36. All right, how about B, square root of 0? That's going to be 0 because 0 squared is 0. Move on here to C. We have the square root of 4 over the square root of 49. You can rewrite that as the square root of 4 over the square root of 49 like this. It's the same thing. We've just split up the radical top and bottom. So here we have 2, right? Square root of 4 is 2 over 7. Final answer, 2 over 7. How about, this one, 0.25, square root of 0.25. Okay, so to figure this one out, drop your decimal for a minute and let's think of it logically. What's the square root of 25? It's 5. So if we multiplied 5 times 5, we would get 25. If we put the decimal back in there, what do we multiply to get 0.25? Well, we're going to multiply 0.5, 0.5 times 0.5, and we will get 0.25. All right, let's look at the next one. Square root of x to the 6th. Okay, so if we're going to rewrite that, I don't remember if you guys remember how to do rewriting these radicals as fractions, but we would rewrite it as x to the 3rd taken to the 2, taken squared. So when we are multiplying, or when we're taking an exponent to an exponent, we multiply here. That's how we end up with this. So to get the square root of x to the 6th, so now we've gone back a step and we've gone to here. To take the square root of it, we would square our, or take the square root of our square here to get rid of it, and we would just be left with x to the 3rd. So we broke it down a step. Here, let me write that out for you. And we would say x to the 3rd squared. So now our squared and square root would cancel out, and we would be left with x to the 3rd. Okay. Look at the next one. Let's take this one apart. This one's different because we have a coefficient right here next to our variable underneath the square root sign, which we didn't have up here. So you actually have to take the square root of everything underneath the radical sign. All right, so if we take the square root of 9, we're going to be left with 3. Now let's do these steps for this one. We could rewrite this as x to the 6th squared, right? And then if we took the square root of that, we would just be left with x to the 6th. So your answer would be 3x to the 6th. All right, let's look at this one. We're only taking the square root of what's underneath this radical sign. And so square root of 81 is 9. And there's a negative out front, so we just transfer that over. All right, so here on H, we have the negative square root of 81, and we haven't learned imaginary numbers yet. Hopefully we'll get to them this year. So this one is just not a real number. Anytime you see a negative sign under the radical, you need to first see what exponent your number is taken to. So it's out here. This is not in parentheses, and it's so it's not like this with an exponent here. That would be a different answer. So we don't have that. So anytime you see a negative sign here under the radical sign, not a real number. Unless it's like a cube or a fifth or something, and then it can work out, but not for a square root. Okay, so I would like you to do practice 1, A through H, at the bottom of page 596. Press pause on the video and we'll check the answers in a second. All right, practice 1, letter A, hopefully for letter A, square root of 49, we all got 7. For B, 0 over 1 is 0, so square root of 0 is 0. For C, hopefully you rewrote it as the square root of 16 over the square root of 81, which is 4, then over 9. For D, can be rewritten as 0.8, 0.8. 0.8 times 0.8 gives you 0.64. So we would have 0.8 squared equals the square root of 0.64. Okay, so E, z to the 8th, we're going to pull it out, right? Z to the 4th squared. So that gives us z to the 4th. 16, that's a letter B. 16, b to the 4th. You have to square everything under the radical sign. So you should get 4b squared. The negative square root of 36 should give you negative 6. And then h, the square root of negative 36, is not a real number. Okay, let's move on. Okay, let's look at finding cubes. All right, so cube roots. Now I'm on the bottom of page 597. And their first example down there is 2 to the 3rd. So that's rewritten as 2 times 2 times 2, which gives you 8. Page. Another one would be, so this is a very used cube root. So you could write that as the cube root of 8. And you just have to remember that you're going to rewrite it as 2 times 2 times 2. So it's the cube root of 8 is 2. All right, how about this one? The cube root of 64. So what times what gives you 64? All right, so it's going to be 4. 4 times 4 times 4 gives you 64. So 4 to the 3rd gives you 64. So the cube root of 64 is 4. All right, how about this one? Another very popular one. Let's go ahead and throw a negative in there because we were looking at some negative roots in the last example being not a real number. So here, it actually works out to be a real number, even though you have a negative sign. All right, so what times what gives you negative 27, okay? So this is gonna be negative 3. So let's look at it and see how it works. Or you could write it like this, negative 3 cubed, okay? So negative 3 times negative 3 is positive 9, times negative 3 is negative 27. So if it's the cube root of negative 27, then it works. Your answer is negative 3. And how about the cube root? Let's throw a variable in there of x to the 3rd. So we do it the same way, even though there's a variable there. What times what times what gives you x to the 3rd? Well, that's going to be x. X times x times x gives you x to the 3rd. So the answer is just x. Okay. All right. So please actually, let's go on and do a few more examples, okay? Look at, how about this one? This is example 3, letter A. So we have the cube root of 1, which is just going to be 1, because 1 times 1 times 1 gives us 1 cubed. How about the cube root of negative 64? Okay, this might work. So up here, we did 4 times 4 times 4 gives us 64. So if we do that here with negatives, do we get negative 64? Whoops, getting ahead of myself. All right, so negative 4 times negative 4 is positive 16 times, that's a 4. Negative 4 gives us negative 64. So the cube root of negative 64 is negative 4. All right, let's try this one. The cube root of 8 over 125. Okay, can be rewritten as the cube root of 8 over the cube root of 125. So what's the cube root of 8? We did that up here. It's 2. And how about of 125? Well, 5 times 5 is 25 times 5 is 125. So that is 5. So your answer is going to be 2/5. All right, let's look at the next one. We have the cube root of x to the 6th. Okay. So let's rewrite this. What is the cube root of x to the 6th? We need, just because these variables are here, don't let it be confusing. What times what times what is going to give us x to the 6th? And remember, if you're multiplying exponents, you're adding. If you're taking an exponent to a power, then you multiply. But here, we're just going to multiply exponents. So we're going to add our exponents. So we have x squared times x squared times x squared. So to do that, we're adding our exponents. We get x to the 6th. So our answer, the cube root of x to the 6th, would be x squared. And then our last example is going to be the cube root of negative 27 x to the 15th. All right, so let's break it up here. We know the cube root of negative 27 is going to be negative 3. So we just need to figure out what our variable is going to be. Okay, so again, when we multiply exponents, we add. So we're going to take 15, we're going to divide it by our root, which is 3. So we're going to have 3x to the 5th, negative 3x to the 5th, times negative 3x to the 5th, times negative 3x to the 5th will give us negative 27x to the 15th. So your answer will be negative 3x to the 5th. Okay, press pause, please. Try practice 3, A through E. Okay, so for the first one, the cube root of negative 1, what times what times what will give us negative 1, and that is negative 1. We can say negative 1 times negative 1 gives us a positive 1, times another negative 1 gives us negative 1. Look at B. Here we have the cube root of 27, very similar to this one we did, but a positive number instead of a negative. So the cube root of 27 is 3. 3 times 3 times 3, 27. Look at C, can be rewritten, cube root of 27 over cube root of 64. We just did this one here, so we know the top part is 3. Cube root of 64, I feel like we did that one. Oh, here it is. We did negative 64, so this time it's just going to be a positive number. So cube root of 64 is 4. 4 times 4 times 4 gives you 64. So your answer is 3/4. Let's look at D. When you have an exponent, when you have a variable taken to an exponent, you just divide it up equally by what your root is, because when we multiply those exponents together, we add them. So 12 divided by 3 is 4. So it would be x to the 4th. And if you want to check your answer to get it back to x to the 12th, you would say x to the 4th times x to the 4th times x to the 4th. 4 plus 4 plus 4 gives you 12. Takes you right back here. All right, and look at E. We have to take the cube root of everything under the radical sign. So let's start here with -8. We know that the cube root of +8 is 2. So the cube root of -8 is going to be -2. And then what times what times what gives us x to the third. Again, you can take your exponent and divide it by your root, just x. X times x times x will give you x to the third. So your answer is -2x. All right, let's move on. All right, top of page 599. Let's look at some fourth roots. So here we have the fourth root of 81. So we're looking what we can multiply 4 times to get to 81. So that's going to be 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So your answer is going to be 3. Look at the next one. See, that was A, here's B. The next one is the fifth root of -243. So we want to multiply something 5 times to get -243. All right, and it's a negative, and our root is odd. Whenever your root's odd, you can have a negative sign under the radical. If your root is even, 2, 4, 6, you cannot. So we're looking for something we can multiply 5 times to get 243. This is where your calculator will come in handy. So your answer is actually going to be -3. -3 times -3 is +9 times -3, -27 times -3, +81 times -3, -243. All right, C is the negative square root of 25. So square root of 25 is 5. Put that negative sign out in front. D, the fourth root of -81. Well, we don't really have something that will get us there. So this is not a real number. And the reason you can tell right off the bat without having to do any math at all is this is an even power and we have a negative sign under the radical symbol. So if you see this combination, this could be a 2 or a 6 or any even number, and you see a negative sign here, it's going to be not a real number. And then E says the cube root of 64, x to the third. Okay, so back on the other side, we did the cube root of 64, and that was 4. 4 times 4 is 16, times 4 is 64. So we know it is 4, and then the cube root of x to the third is just x. So your answer is 4x. All right, go ahead and try practice 4, A through E. I'm going to press pause please, and then play. All right, here we have the fourth root of 10,000. So we want to multiply something 4 times to get to 10,000. Well, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So your answer is going to be 10. All right, here we have a negative sign under the radical, and we do have an odd power. So the fifth root of -1 is going to be -1. C, we have the square root of 81 with a negative out front. So that is just going to equal your square root of 81 and put your negative out front. Again, bring it on over. Here we have the fourth root of 625. Okay, so we have an even power and a negative under the radical sign. So this is going to be not a real number. And then here on E, we need to take the cube root of everything under the radical sign. So the cube root of 27 is 3. 3 times 3 times 3. The cube root of x to the ninth, take your exponent, divide it by your root. You're left with x to the third. Okay, good job. let's move on. Turn the page, please. And look at, actually, don't turn the page. Let's look at the bottom of page 599. All right, so now we're just going to simplify radicals. So here for A, we have the square root of -3 in parentheses squared. All right, so if you are squaring, a square root, these two things cancel each other out, and you're just left with -3. Look at B. We have the square root of x squared. Same thing again, square root of x squared is going to be just x, but it's actually going to be the absolute value of x because we don't know if x is negative or positive. X could be -2. Well, that's not a good example. Yeah, it is. It's fine. Okay, x could be -2. So since these cancel out, well, okay, no, let's say x is -4. That makes more sense. All right, so if x is -4 and we square it, then we end up with +16 under the square root sign. Let's plug that in. Let's just try it. Okay, let's say that x is -4. All right, so going in order here, we would square this -4. So we would end up with the square root of 16, right? -4 times -4 is 16. Now the square root of 16 is 4, right? So that's why we have to use absolute value, because even if x is negative, our answer will still turn out positive. Okay, look at C. For C, we have the fourth root. Whew, sorry, keep yawning. Of x minus 2 to the fourth. Okay, so our root and our exponent here, our power, are going to cancel out. So we have x minus 2. But again, we're going to have to put it in absolute value because we don't know if our x is negative or positive. But once we take it to this power, it's going to end up being positive because we have an even power here. Okay, let's look at D. We have the cube root of -5 in parentheses to the third. So these will cancel out and it will just be -5. To show you how that works, if we take -5 to the third, we have -5 times -5, which is +25, times -5. Here, let me write that out. Okay, so here we have +25. And now we're going to multiply it by -5 again. We're going to get -125. And the cube root of -125 takes us back down to -5. Okay, let's look at E. We have the fifth root of 2x minus 7 to the fifth. So again, these cancel out and we're left with 2x minus 7. However, this is an odd root that we're taking, so we don't need the absolute value sign. We only need the absolute value sign when it's an even root, because an even root always gives us a positive answer. That's why you can't have a negative here under the radical sign with an even root. So we're just left with 2x minus 7. F, we have the square root of 25, x squared. All right, we have to take the square root of everything under the radical sign. This is an even root. So we can start here with 5. And then if we take the square root of x squared, we have to have a positive number. So that x is going to be put in the absolute value sign because it's an even root. And look at G. Here on G, we have the square root of x squared plus 2x plus 1, all under the radical sign. All right, so the first thing we're going to do is we're going to factor this. So to do that, we're just going to leave it under the root. We're going to open it up. We're going to factor it. We have x, and then here we're going to have plus 1. So this can then be rewritten as the square root of x plus 1 squared, because that's what we're doing. We're multiplying x plus 1 times x plus 1. That's how we get here. Now we can drop the radical and the exponent because they will cancel each other out. However, this is an even radical, so we have to put it in the absolute value sign. So there you go. The absolute value of x plus 1. Okay, I'm going to press pause. Please turn the page to 600 and do A through G at the top. Practice 5, A through G on the top of page 600. All right, press pause. All right, let's look at our answers here. Here we have -4 squared, and we're taking the square root of that. So -4 squared is going to be positive 16. The square root of 16 is going to be 4. Next, we have x to the 14th, okay? To take the square root of that, remember this is our root right here too. If it gets confusing, you can just divide your exponent by your root. So you end up with x to the 7th, but it's a positive root, so we need the absolute value. All right, next we have x plus 7th to the 4th root. So this is an even root, so we have to use absolute value. These cancel out. We just have x plus 7, absolute value of x plus 7. All right, look at the next one. We have -7 cubed taken to the 3rd root. So these would cancel out, and we're just left with -7. E, we have 3x minus 5 to the 5th taken to the 5th root. All right, it's an odd exponent, so we don't need absolute value. They just cancel out. We're left with 3x minus 5. And F, we have 49x squared. We have to take the square root of everything under the radical signs. The square root of 49 is 7. The square root of x squared is x, but it's an even root, so we have to use the absolute value sign. And then here for G, first we're going to factor. So let's factor. Okay, so we have x times x, and we're going to multiply something to get 64 and add to get 8. To add to get 16. So we're going to use 8. Everything's positive. Okay, so now we're going to rewrite this as the square root of x plus 8 squared. Now our root and our exponent are going to cancel out. It's an even root though, so we need to use absolute value. We're left with x plus 8. Absolute value of x plus 8. Good. All right, moving on. Look at example 6 on page 600. So now we're going to look at functions of radicals. So here it says if f of x equals the square root of x minus 4 and g of x equals the cube root of x plus 2. It says find each function value. Okay, so here all you have to do on these is plug them in. That's it. So on A, it says f of 8. So all you would do is you would take 8 and plug it in. First, come to your f function. You would plug in 8 everywhere there's x. So we would have the square root of 8 minus 4. So 8 minus 4 is 4. So that's the square root of 4, which is 2. Okay, look at B. B says f of 6. Okay, so we're going to just plug it in. We're going to come to our f function. We're going to plug in 6 here. So here we would have the square root of 6 minus 2. I'm sorry, 6 minus 4. I'm just making up my own numbers, which gives us the square root of 2. And that's as far as you can go with that one. So final answer, square root of 2. C is g of negative 1. So we're going to come here to our g function, and we're going to plug in negative 1 where we have x. So we have the cube root of negative 1 plus 2. So negative 1 plus 2 is just positive 1. So we have the cube root of 1, which is 1. And then D, we have g of 1. Okay, so we're going to plug in for g of 1. We're going to plug in positive 1 for this x here. So we have, well, I'm just writing x again. We have 1 plus 2. So g of 1 gives us the cube root of 3. And that's as far as you can go on that one. So final answer. Okay, press pause and do practice 6, A through D. All right, look at A. We have f of 11. So we're going to use our f function here. We're going to plug in 11 where there's x. So we have the square root of 11 plus 5, which gives us the square root of 16, which is just 4. All right, look at B, f of negative 1. We're going to plug in negative 1 for x here. We're going to use our f function. So we have negative 1 plus 5, which gives us the square root of 4, which is 2. Okay, C is g of 11. We're going to use our g function here. Cube root of x minus 3. So if x is 11, we have 11 minus 3. So we have the cube root of 8, which is 2. And then here we have g of negative 6. So we're going to plug in negative 6 here for x. So we have the cube root of negative 6 minus 3, which is the cube root of negative 9. And that's as far as you can go with that one. Can't go any farther. Okay. That is it. We are not going to graph today. So if you would please turn to page 602. And the homework is going to be page 602 to 603. And we are going to do number 4, number 12, number 14. On 14, you can use your calculator and get a decimal, okay? And round to the hundredths. So 3 place values, okay? So round to the hundredths on that one. Let's also do 20 and 28. Let's see. Let's go with 38 and 40. 1, 2, 3, 4, 5, 6, 7. And 42. Let's go with 48 and 52 and 54. Okay, so please do that before you leave class today. Do these, scan them and upload in Google Classroom. I will create an assignment on there for you to put those, for you to put your work so I can give you a grade for today. Okay, that's it. Have a great weekend. Bye-bye.